teaching pre-calc this late, but that's okay. It's, 10 o'clock. Usually my pre-calcs are done by 10. That's all right. Couple of reminders off the start. First off, don't forget that you're on your own for P1, P2, and P3. If you have those done already and want to turn those in, that's great. I am asking that if you are my grading student, that you turn them in separately. So like turn in P1. If it's 2 pages, staple those 2 pages together. And then turn in P2 separately, and then turn in P3 separately. P4, if you got that done too, that's great. Today we'll be able to do P5, or we'll finish P5, I should say, today. We'll get a good start on P7 today yet. And so if you want to do all that this weekend, that's great. Just as an FYI also, come on now, there it goes. Just as an FYI, on It's Learning, okay, all of you, Hill or Linsmeyer ones, all of you should be enrolled in Pre-Calculus LB1 Linsmeyer, okay? And so in there, for all of you, if you launch that, comes up to a basic page. This is what my page looks like. I don't know what your student page looks like, but what you're looking for is you are looking for resources. In resources, you will find Chapter P. If you click on Chapter P, you will find all of the stuff that we have done so far. Like these first 2 lines, here's the blank note sheet that you got on Wednesday. Here's the filled in note sheet after Wednesday. Here's the blank note sheet that you got yesterday. Here's the screencast from yesterday. And then there's the hard copy from yesterday too. Okay, so the P5 Day 1 notes are on there. Okay? Today, the blue packet will go on there first. And then the screencast will go on there next, and then the hard copy will go on there last. So it kind of flows in that pattern. Usually there's not a handout though, so usually it's just screencast and then hard copies of notes. But I also want to point out, in this folder called Selected Practice, in there you will find the Chapter P assignment list if you lost that half purple sheet. And then you will find all of these different ones. So like let's say you got a question on P2, you click on P2, and then if you go over here to download, you can download it right on your phone and you can see it. You can download it on your computer, whatever you want. It's a PDF, and there's the worked out solutions for P2. Okay? Now, that is used or meant to be a reference, a resource for you, if you will. It's not meant to be, oh, Linsmeyer did my homework for me. Okay? Right? Trust me when I say this, I do things differently than everybody else. So for my grading students, I will know if you're copying. Okay? Because I see how I organize it, and very few people would organize it in that way. Okay? All right? So that's there for you. And then today I will put up P5, and if I get done with it, I'll get done with P7. So, okay? So there's that. All right. So, there it goes. So on the bottom of the back side of yesterday's note sheet, we'll do that one example, which we're actually going to do twice. Okay? So there are 2 different ways to solve equations graphically. Okay? Especially if, well, it really doesn't even matter what's on either side. So you got a left side and you got a right side of your equation. We want to solve it graphically. Okay? So one way of doing that is you can put each side in as its own function. Okay? So if you go on your calculator and you open up a graph. Oops. Okay. The one side of the equation is the absolute value of 2x minus 3. Now, just to remind you of where the absolute value is on the inspires, there's this little book-like key by the 9, 2 over from the 9, and then there's this other one, and then there's the 9. I want that other one right in the middle of the 9. That's the shortcut key. And in said shortcut is a bunch of different things. You got fractions, exponents, radicals, e's, logs, not combination functions. I forget what they're called. Why am I blanking on multiple functions in one? That'll bug me for the rest of the day. Matrices, degrees, minutes, seconds, integrals, limits, all that stuff. But this blue one right here, that blue one is the absolute value shortcut. And so if you double click on that, it pops in the absolute value for you. And then you can just type in 2x minus 3. And then when you hit enter, there's your absolute value function. Okay. Now, we have to do the other side of the equation. So I'm going to hit tab, and then I'm going to type in x squared. And hit enter. Okay. So there is my two functions. Now, what I need to do is, clearly this red function is going to intersect this blue function somewhere up here. So I can grab, for you, you can scroll over anywhere, grab onto it, and you can pull that down to see that intersection point. Okay. So now we just have to find those intersection points. Menu, analyze, intersection. There's one of them. Menu, analyze, intersection. There's the other Okay. So the points of intersection, are at -3, 9, and 1, 1. That's the points of intersection. But we're solving this equation. We're just using graphing to solve it. So really what we're looking for is just the x values of those. So the solutions to this function would be x equals -3 and x equals +1. Those are the solutions. Okay. The points are just where they intersect. Okay. Questions on that? Okay. The other way of doing that exact same problem is you can do it all in one function. Okay. And in order to do it all in one function, the first thing that you have to do is you have to set your function equal to 0. So you've got to move everything onto one side. Now, it really doesn't matter which side you move it onto. You're going to get the same answer. Okay. But that function then that you're graphing is going to be that one side of your equation that has all the stuff on it. So now, when we would graph that side, I'm a big proponent of new pages. I like things nice and pretty. Absolute value of 2x minus 3, and then I go over 1, and then I go minus x squared. And now, when I graph that function, I get that. Kind of a funky little graph. It looks kind of like an absolute, or a parabola, an upside down parabola, and then we got a little But now, what am I? Yes, ma'am. Yours is upside down. That's okay. Same thing. Yep. Yep. Because you did the x squared. Yeah. The other one. Yep. Yep. Because it goes through the same 2 points that I want. Yep. Okay. Here, I'll put them both on there. Tab. So then we would have done x squared minus absolute value of 2x minus 3. That one will be in pink. Okay. So either one of those two. Okay. With me? Okay. So now what am I looking for instead? I'm not looking for intersections because we only have one of those on there. But I'm looking for zeros. Yep. So now I need to analyze and find the zeros. Maybe not. Going too fast. Why is it not letting me find zeros?
Because you have to select the graph first.
Oh, it wasn't selected. There we go. Menu, analyze, 0. Still not letting me. Oh, there it is. Lower bound. There it goes. There it goes. Now it's popped in. Okay. I should be playing like elevator music while I have to go over and adjust these. Da da dee da da do. People on the interwebs are going, huh? Okay. So again, we're looking at 0 points on the graph, but because we're talking about a solution, I'm only talking about the x coordinates of those. And it ends up being the same. Not quite sure what that little thing is right there. So we'll get rid of it. Okay? That concludes the page. Now we're going to the packet. Okay. So, just moving stuff around here. All right. So, absolute value type stuff. Okay. Remember, if I said solve for me the absolute value of x is equal to 5, what is x equal to? 5 is one of them, right? Okay. Is there another one? -5. Okay. Remember, absolute value is the distance a number is from 0 on the number line. Okay. So 5, So all of the numbers 5 units away from 0 are positive 5 and negative 5. Okay? So in terms of what you're doing there inside your brain, you're taking the inside of the absolute value and you're setting it equal to the other side. Okay? And then you're taking the inside of the, oops, I forgot the S and the I, indes. Spelling was never my strong point. The inside, and you're setting it equal to the negative of the entire other side. Okay? Now, if we tweak that and we say, now I want the absolute value of x greater than 5, I'm still going to look at 5 and negative 5 as my endpoints. Okay? But now I want to be bigger than that 5. So is that on the outsides or is that on the inside where the absolute value is bigger than 5? That's the outsides, right? And because this is just the straight up greater than, I am not going to include those two numbers. Okay? Now, I will show you here how that's how I draw it. Okay? How your book draws it is a little bit different. Okay? So I want to take a moment here to show you how your book actually draws this. Okay? Your book would draw this exact same scenario. It would draw it like this. And I'll actually try and use the same colors. See, your book has the option of doing colored printing on top. Okay? Now you, as a person probably just using the pencil, don't have that option. So you got to make it clearer somehow so that you can see it. But those two mean exactly the same thing. Okay? In interval notation, okay, this would look like we would be going from negative infinity to negative 5, and I'm going to union that with 5 to positive infinity. Right? That's how that would look in interval notation. Questions on that? Part C here then, again, I'm looking at negative 5 and I'm looking at positive 5. But now, am I looking outside the 5s or am I looking inside the 5s? I'm looking inside the 5s. And on top of that, I'm including the 5s now, right? Because I'm equal to. So that means I would fill that in with a dot, and then I would make a little handle on that one. Okay? The book the book would, instead of going with parentheses there, the book would go with, oops, I went the bracket the wrong way. We'll just reset. Happens. Not the first time today I've made a mistake. The book does brackets and then fills it in there. Okay. In interval notation, that would be bracket, -5, comma 5, bracket. Okay. Brackets include, parentheses exclude. Okay. Questions on that? Okay. Now, if we are solving, oh, why did you move all the way over here? Come back. Go to your home. Now, if we're solving, okay, we can solve it algebraically, okay, or we can solve it graphically. So we'll solve this one algebraically. Okay. So the first step is you're going to write two equations without the absolute value. So my first equation is going to be that inside equals the other side. My other equation is going to be the inside equals the negative, the opposite of that other side. Okay. And then I solve both of those equations. I'm going to add 1 all the way across, so that's going to be 2x equals 6, and 2x equals -4. I'm going to divide by 2 all the way across, so that gives me x equals 3, and x equals -2. Okay. Now, I need to put those on a number line. Okay. And logic tells me, am I thinking outside of that range, or am I thinking inside of that range? Thinking outside. Okay? I'm thinking outside because I want that to be bigger, not including okay. Remember, alligators and crocodiles, whichever one you want to call them, they like to eat the bigger thing. In this case, the bigger thing is the absolute value, so I want that to be bigger than 5, which mathematically says that I'm on the outsides of there. Okay? So then I need to convert that into interval notation. So I'm going to go from -infinity to -2, and I'm going to union that with 3 to infinity. Good to go on that one. Now, let's solve that exact same problem, but now let's solve it using the graphs. Okay. So, again, I'm a proponent of new page. Add graphs. Okay. So my first function is going to be the left side of my inequality. 2x minus 1. There's my function. The next function is going to be the right side of my inequality. Now, because we've already solved this algebraically, we know that those intersection points are at the point 3, 5 and negative 2, 5. Okay? But if this were our first time through this problem, we wouldn't know that. So next, what we've got to do is we've got to find those intersection points. So we did find those intersection points.
Here's where that elevator music comes in. Okay. Now, again, logic is going to tell you that we want to know where my absolute value function, which is the green function, is bigger than 5, which is the peach. Peach on that one? Which is the peach function. Okay? So, where is green bigger than peach? Well, that happens, let's go red. That happens up here. And that happens over here, right? Okay. Where it's above it. If it were reversed, if it were less than 5, it'd be where we're below that one. And then we convert that into interval notation. So that would be negative infinity to negative 2 unioned with 3 to positive. Questions? Don't forget P1, P2, P3, P4. You can do P5 now, because we're done with P5. And you can get a very good start on P6, or I almost said P6, P7. You can get a really good start on P7. Because the only thing that we have to do yet in P7 is vertical motion. Okay? Right now, I think we're still going to have the test next Friday. Okay. Right now, it's still looking like, because we've got Monday and Tuesday yet to do the 2 things that we need to do. Wednesday would be our review day, and then Friday would be our test day. And then we would just go on to like the first section in chapter 1.
Are we going to finish the rest of these notes on Monday?
Monday and Tuesday, yes. Yep, we'll finish up. Okay.